Good evening, ladies and gentlemen. I am Dilan Tilanga from Building Services Engineering Sectional Committee, and I welcome you all for the public lecture under the title of National Fire Regulations Going to an Unknown Territory. To begin with the lecture, let me briefly create the background for this topic. Capital of Sri Lanka is being surrounded by high-rise buildings day by day, and its designer's responsibility to ensure life safety of each occupant in those buildings. I hope you agree negligence to life safety is a criminal offense. Especially those who ignore fire regulations too will endanger human lives who has the right to live. Sri Lankan fire regulations recently revised in 2018 with a comprehensive attention for high-rise and super high-rise buildings. In this lecture, we are about to discuss important aspects of designing and maintaining fire systems and life safety systems for those skyscrapers. We are delighted to declare we have a prominent character for this lecture from fire engineering sector, who is Group Captain Kolita Sri Nissanka. He is a fellow member of Institution of Fire Engineers UK, MBA holder from University of Colombo, and holds MSc in Defence Studies. He was the Chief Fire Officer for Sri Lankan Air Force for 23 years and officer in charge of the Colombo Fire Brigade since 1996, soon after the Central Bank major fire incident. Further, he is a member of Drafting Committee of Sri Lankan Fire Regulations and a visiting lecturer at Univotech, University of Vocational Technology. In addition, for last 10 to 12 years, he holds a general manager position of one of the leading fire services provider in Sri Lanka. Without further ado, let me welcome our resource person of the day, Group Captain Kolita Sri Nissanka, to proceed with the lecture.
Yeah, thank you very much and welcome to the lecture. Thank you ISL for inviting me for the lecture, and I think I will have 1 hour time to deliver, and maybe after 1 hour you will have a time for question and answer. So we will carry on the lecture without any interruption, and after the lecture we will go for a discussion. Right, now just I am glancing through the last 20-30 years, what happened to Sri Lanka in the building industry, what high rises we have seen in Colombo. Now these are the key buildings. Some are half done, some are yet to complete. And if you go to UDA website, they have a plan for 2030, and you can see there are so many buildings coming up in Colombo. Now after all, these buildings are iconic buildings and we like to see them, we like to go and live there, and finally we have to be responsible for life safety. Whether it can be a nice building, very iconic building, but finally it comes to life safety, somebody is responsible there. Right. Now since this is happening in Colombo, I will just show a video what's happening in outside of Colombo. I think some maybe have seen. Just a small clip. This happened maybe 2-3 weeks ago in Kandy, and Any one of you here would like to throw their child out of the window? Anyone who wants to throw his child out of a window in a situation like that? Or you want to be a part where you have designed the system and you let other people throw their children out, or they jump out from a window due to your negligence? So that's the question we need to answer. Now I just want to share one slide. I am showing where this Colombo Fire Brigade is located. We have 4 stations in Colombo Fire Brigade with response to fires in the city of Colombo. 2 are, I don't think it's very clear, but we have 4 stations. And this is a US test done on a room fire. Now here it shows within 3.5 minutes entire room come to a flashover point, that is total room is burning. So you have 3.5 minutes time to respond, and you have 4 fire stations in Colombo, and you know the traffic, how long it will take to reach the incident, and you reach to the time to reach 30 floors or 40 floors, what time will take? My sequence will be, I will just reviewing the giving an overview, regulation, specification and standard. What is the clear distinction between, what is the difference between them? The fire brigade requirements. What do you mean by a fire brigade requirement? CEDA regulations, important aspects of CEDA regulations, and we will go for questions. Now, who is the regulator? I was trying to go through the web and find out who is the regulator of the fire. Who is in charge? Who is the implementer? Now we have the Motor Traffic Act, we know the regulator, we know the implementer. There are regulations, you go on the road drunk, you will get fined. Now here, who is the regulator in the fire? Now the buildings are regulated by the UDA and the urban councils, and when you want to put up a building, you need to go to either UDA or municipal council to get the approval. Similarly, CEDA, which has now got an act passed by the parliament, it talks, we'll just glance through what it says. It's passed in 2018. Every contractor registered under the Construction Industry Development Act number 33 of 2014 shall carry out any identified construction work under the said act according to the procedures and standard as specified in the first and second schedules respectively. It clearly says you have to comply, and we'll see what is the 2 schedules. Under schedule 2, they are referring to 2 regulations. The CEDA fire regulations and the CEDA specifications. There are 2 documents. This is fire regulation, this is a specification. This was done in 2016, this was revised in 2018. Now there is another party coming into play, that is the authority having jurisdiction. Now here we call, what is the authority having jurisdiction is the local fire brigade. Now the local fire brigade, so far we see them as the implementing body. Finally, once you do your system, you want to get the certificate, you have to go to the fire brigade and get the certificate. The best part is the fire brigade has their own requirements. I will show one of the requirements. Now this is a requirement given to a project. They give a requirement saying this is a fire brigade. You go to the fire brigade with your drawings, you have to sit there, you give it to them and they will give you, this is the requirement. So see, you give your requirements, you are the regulator and the implementer, both one part. What will happen? So I don't want to comment further on that. So that's why we are focusing on the CEDA, and we are trying to tell the fire brigade, you need to comply with the CEDA fire regulation, that is the governing regulation in this country. So on 30th of next month, we are going to have a seminar. We want to call all the fire chiefs at the CEDA, educate them on the fire regulations. Now, what is a regulation? Regulation, I got it from the Wikipedia. A rule or order issued by an executive authority or regulator agency for government and having a force of law. So there is a regulation is having a force of law. When you have a force of law, you can be convicted by a court of law. The specification. What is the specification? We have a specification. The specification we define as act of identifying something precisely or stating a precise requirement. We call this document a specification. Later we want to call it as a code of practice. Say you have a fire detector, we give a specification for the fire detector. We have a fire pump, you give a specification for the fire pump. So the regulation and the specification are two different. Regulation says what you need to do. You need to install a fire pump. The specification will tell what type of fire pump you need to install. So there are two distinguished areas, specification and regulation. Then what are the standards? Something considered by authority or general consent on a basis of comparison approval model. Now here we normally focus on NFPA, National Fire Protection Association from the USA and the British standards. Now people are asking, why won't you go for German standards, say Japanese standards, later why not Chinese standards? They will come and tell all this. Now we have decided to have our vehicles right-hand drive. We have decided that long time ago, and we imported vehicles which have a right-hand drive. But there are other countries who have left-hand drive. So we can't argue. So the left-hand drive vehicles also can go at high speed. But here we have decided this is we are focusing, we are referencing these two standards. Then the listing. We have listing. What is it mean by listing is a certification from a third party. The NFPA and the BS are standards. Standards will say, now if you talk about sprinklers, the NFPA will say, go by sprinkler standard NFPA 13. So it will give you how to design a sprinkler system for a particular standard. Now recently I had a problem. We supplied equipment and equipment was UL listed. UL listed means it complies to NFPA standard, because NFPA is a USA standard. UL is a USA governed body, and anybody can get a UL certificate. It doesn't need, even Sri Lankan we can produce a product and get a US certificate. So this project manager was telling, you have given me a UL listed pump, but we do our electrical design as per BS. So your fire pump electrical panel does not meet our standards. So I was feeling sorry to him, because you need to define NFPA and UL are different, BS and LPBC are different. Their standards are different, right? So when you say your fire pump has to be listed, that means your fire pump has to be listed, certified by a third party. Say your fire panel has to be listed, that means it has to be certified by UL, LPBC. Even the DIN standards are there, but focus is on ULFM and LPBC. Fire regulation initially published in 1997, revised in 2006, and latest revision is 2018. It took more than 2 years to do the revision, and people from IESL, Institute of Architects, Institute of Fire Engineers, Fire Brigade, everybody was involved in this committee. So it was an idea of all professionals in the field to put this document through. Now fire regulation, this book we had divided into 8 chapters. Now I will not have time to cover all the 8 chapters, but the things I have highlighted in red, we will just go through that to see what are the important areas. New edition focus on few key things. That is, one is the residential dwelling, because this regulation has purpose group. Purpose groups mean, say now this hall is a lecture hall and this is an institute. So this the institute goes as a purpose group as institute. If you take a hotel, the purpose group is a hotel. If you take a office, it's a hotel. Now earlier we didn't have a purpose group for the apartments. So apartments, people who are constructing apartments had various ways of getting out from the regulations. If you go around, you go to apartments, we say any building over 30 meters has to be sprinkled. You check the apartments, they are not sprinkled. But since there were no purpose group, they had some escape path. Then the high-rise building. A high-rise building is a building which is more than 30 meters high, up to 60 meters. And now the new concept came, a super high-rise building. What is a super high-rise building? It's a building that is more than 60 meters high. If you take 3 meters of floor, that is 20 floors and above. And we call them a super high-rise building. For super high-rise, basically we have stringent regulations, and we'll touch on few. So the first chapter talks about the administration and application of the regulation. Now under this chapter, we have the CEDA has appointed a technical compliance and committee on fire regulation. So what they will have, they have a 5-member committee. They are responsible to advise the authority having jurisdiction on any technical matters which such as advice is required to take a final decision. Say you take your plan to the fire brigade, then they come on a dispute and say I don't want to sprinkler my building, but I cover certain regulations. If there's a dispute, the client can come to the CEDA and make their complaint. On the other hand, it has to be very careful. The occupier who is occupying a building, he knows the regulation and he occupies an apartment. He knows that that apartment is not sprinkled and he sees the regulation that you need to sprinkle. Then the developer is on a question. So then this committee will take a decision whether to put sprinklers or what need to be done. Investigate and recommend the course of action to be taken in respect of any dispute referred to CEDA. So that mechanism will come maybe another 1 or 2 months, it will be enforced. So we don't want people to come to CEDA and stay in a queue and say my building, this building ABC. There will be a procedure laid out. A payment will be charged. So there will be a procedure put down by the CEDA. Then the system install. Now today what happens, anybody can do any systems. If I want to start up a business tomorrow, I can do a fire system tomorrow. We strongly say any contractor has to be registered with the CEDA. There are under categories you can be registered, and only people who have qualified, who qualified for certain requirements can do high-rise buildings or super high-rise buildings. Now what about these Chinese guys who come and does? It's a big question now, whether they are authorized to do that, and any violation, how can we take them to courts? So those all are questionable. One thing we must say, when we had this regulation, the CEDA published on the web, and we waited for 1.5 months or 2 months to get public comments. Fortunately or unfortunately, we get only one guy commenting. So where were others? We had a seminar, there about 200 people came, nobody commented, nobody said a word about the regulation. We wanted public opinion, your input to at least revise or do additions to amend the regulation, but nothing happened. Anyway, now the system, the document is out, you can buy it, and is governed by an Act of Parliament. So the people who does any installation are under certain law of this country. Maintenance, people neglect maintenance, but under this act, people has to maintain their systems. Owners and occupiers, any high-rise, super high-rise building, every 3 years they have to do a fire risk assessment and get a certified from a qualified person or the authority having jurisdiction. About the efficiency of the fire protection system, the means of escape, condition of the refuge flow. Those are the areas that they will have to go and do a check. Stop work orders. It doesn't happen here. Any site does not abide by the regulation, the fire chief can go and do a stop work order. So time to come, it should happen. It should happen. I hope the fire brigade had some guts to do that. On the receipt of some notice, stoppage work, then again he had to give it in writing. Okay, we didn't do the sprinklers, but now we are compliant with the regulation. Yeah, we are giving in writing that we will comply with the regulation and proceed with the work. Then the chapter 2 talks about the means of escape. If you are engineer involved in this field, go to the new buildings which we had done recently. Check the means of escape. You will see those means of escape in some buildings are not done properly, especially the smoke-free lobby. There are no smoke-free lobbies in some very key buildings here. I don't want to mention names, it's not done, right? But if you go there, your means of escape is not protected, which means in case of fire, when you are going out, you will be under the smoke, you will not see anything, right? The design of smoke lobby shall not impede the movement of occupants through. That means the clear passage should be there for people to move through the smoke-free lobby to the escape, that is the firefighting staircase. Flow area of the smoke detector shall not be less than 3 square meters. And if the smoke-free lobby is taken as the firefighting shaft lobby, it has to be 6 square meters space has to be there. You can't have 1 meter stretch covering 6 meters. That means 1 meter width or 6 meters you can't have that. Minimum should be 2 meters. Adequate space must be there. Then the chapter 3 talks about the structural fire precaution. That I will not go into detail. That is to prevent the fire spreading from area to another area. Right? Now the Sri Lanka standard today is the compartmentation size is 2000 square meters, and if the building is sprinklered, you can go up to 4000 square meters. So now if you take this hall is 6000 square meters, you can't have an open hall like that for 6000. If it's sprinklers, you need to compartment it for 4000, you have to divide. That is mean by compartmentation. And so even flow wise, now you have seen a lot of people talk about Denfell fire. People are being brought here to give lectures, right? We invite them, right? What happened? There are no barriers. The fire spread to the outer wall cladding, and smoke went through the inner ducts. Even if you go to buildings today, I check half of the building, the ducts are not sealed. There are no protective sealing done. And sometimes they come to the fire brigade and ask, say, can we only seal the electrical duct? Because the water duct doesn't carry any electrical components. So there won't be any smoke building up in the plumbing duct. No. There can be smoke moved through the plumbing duct to the other floors. So in a compartmentation, if the flow, say a flow is 1000 square meters, you need to seal it. Every 4 floors you need to seal it to make it a compartment. But sometimes the fire brigade asks, after 30 meters each floor you need to have compartmentation. That means you need to seal off at each floor. This CEDA fire requirements or the fire regulation is the minimum requirements. The authority having jurisdiction can increase the requirement or add so many other features. Then another thing came into the discussion or into the regulation is the refuge. Now any building, a super high-rise building which is over 60 meters has to have a refuge area every 10 floors. Which means you count the 10 floors from the top, not from the bottom. Because people from top will travel down. So every 10 floors you will have a refuge flow and a refuge area for people to stay until the fire is being fought and people are evacuated slowly. How do you calculate? You take the occupancy load of the 10 floors, you take 50% of that, and that area for that you have to keep minimum of 5 square meters per person. I will not go into detail how you calculate the occupancy load. If you take a hotel occupancy load is per room 2 people. If there are 100 rooms, 200 people. So 50% is 100 people. 100 into 0.5 is, that's the area. It's a very simple. And you need to have cross ventilation, 25% area on 2 sides, right? So the refuge flow is a very important aspect in a super high-rise building, and you need to ensure that your building has that refuge flow. Why do you need a refuge flow? Because people at top floors, they cannot come to the ground floor within 3 minutes. So they will come down the staircase, fire staircase, they'll come and they rest maybe at the refuge floor and come down like. So if the building is on fire for 3 hours, 6 hours, so people can travel, not wait there till 6 hours, maybe within 1 hour they should come down, because the walls are given for maximum 3 hours fire rated, so they should come down. Now this is the other sector which is very important, the fire detection and alarm system. Here also we must say this is not the best requirement, this is the minimum requirement what the CEDA says. Over and above you can design your system. Say some international hotel, they will have their own standards. Their standards will be much better or much higher than the CEDA regulation or even the fire brigade requirements. So in that matter you need to comply to those standards. Now the regulation very clearly give a very brief guideline. Now say you want to design a building, you want to know whether this building needs a fire detection system or not. Whether I should put detectors, whether I should call points, whether I should put voice evacuation, whether fireman evacuation. So we had made it very simple. We are given a table on this. Table 14 says a purpose group is given, height is given, then the manual point, fire detection, voice evacuation, fireman communication is given, not required, a table is given. So it's very easy to refer. You are designing a building, you refer this table and see, yes, this building requires, that's the regulation. Then you further go on to designing the system as per NFPA or the BS or the fire specification. One thing is, like any building which is having over 100 detectors should go for an addressable fire detection system, not a conventional system. That is in the regulation. So this table is a very quick reference guideline. Fire alarm control panel has to be on the fire command center. Any high-rise building or super high-rise building will have a fire command center 10 square meters in size. Now some buildings very difficult to find this fire command center. Why? Because the ground floor is the most important floor in a building. High value commercially you can put a shop there. If you can put a shop, why you are putting a fire command center? Commercial value is there, but it's very important you have your fire command center at the ground floor. Power requirement, at least 2 power, main and the battery power should be there. How to check the battery power? You have to keep the fire panel for 24 hours on battery and check the alarm for another 5 minutes. So if you are going to check a fire system, you need to switch off the main power, keep the fire alarm panel for 24 hours. After 24 hours you sound entire alarms. For 5 minutes the battery should be able to have the system going, have all the sounders working. On normal operating conditions, if you want to go and check a system after the installation, you have the entire alarm going for 30 minutes on the battery. So if somebody had not done the proper battery calculation, what will happen? After 5 minutes, the panel will go to a halt. That is the requirement. Sound level 65 decibel, 10 decibel above the ambient. Noise level, which is whichever not exceed 120, and especially in a hotel or apartment, 75 decibel at the bed head, at the pillow. All doors closed. I don't think any one of, I have not checked. Any of us, maybe even the fire brigade, I doubt they check. You have to really check, right? And if a auditor comes, he will check. There are seats here. Yes. Visual alarms. Why you should have visual alarms? Now in a hospital, can you have the alarms going, or a false alarm, or any just initial? Because the fire detection system is there to detect the fire, not to have the alarms going and evacuate the people. It is there to give you a signal saying that there is a fire. People have to react and extinguish the fire, not wait until the entire alarms goes and people run out from the premises. It is not the purpose of a fire alarm system. Where accommodation is provided for disabled people, both visual and audible alarms must be provided. Visual alarms, you must have it 2.1 meter above the floor, less than 150 millimeters from the ceiling. Voice evacuation. What do you mean by voice evacuation? Now people take public address system as a voice evacuation. You can take, provided that the public address system is monitored, if the cables are fire rated, and if a speaker is removed, that it gives a monitoring signal. So the voice evacuation system is the system used to evacuate people, guide people in a case of a fire. And voice evacuation is required in a building where the greater than 2,800 square meters, having total occupant load of 1,000 person, or in an industrial warehouse, the floor area is more than 5,000 square meters. And especially high-rise and super high-rise building, the voice evacuation is a must. Voice evacuation is automatically when the detectors are activated, you give a voice message saying that there is a fire in 29th floor, please be patient or please evacuate, and it will simultaneously give another message to the other floors. There is a fire at 29th floor, 30th and 31st floor, please evacuate. That is the voice. Sounders will only give a sound, it will not give you a direction. So this type of buildings, you need to have voice evacuation system. Then the firefighters telecommunication is another requirement in a high-rise and a super high-rise building. But why do you need a firefighters telecommunication? To speak, for the firefighters to speak within each other inside the building. Now if you go to certain pump house, the pump house is in the basement. Your mobile will not work, there is no way of communication. So you need to have a firefighters telephone communication installed. Every firefighting lobby in the basement, where number of basement exceed 2, firefighting related mechanical rooms, fire service lift, room having smoke control equipment, each area of refuge, and also the fire pump room. The monitoring, the circuits must be monitored. That means if there is a cut or breakage, a defective in the cabling, it must be monitored by the fire alarm panel. That means it is 24 hours the system is monitored. The two-way telecommunication system must have 5 telephones working each simultaneously. That means if 5 firefighters go to 5 floors, they can plug in their phone and 5 people can simultaneously talk. You can't have one telephone at a time talking. That is not approved. So you have to have 5 telephones simultaneously where people can speak. temporary building construction must have a siren. That is something we have put it new. Right. Then that is fire detection. Main areas I have covered. If you go to the document, there are so many things you need to abide. Please refer the document if you are designing a system or if you are the developer. It's always better. I have been in the construction field for maybe last 12 years. Right? What happens? People don't decide at the initial stage. The meetings are there to come and fight with each other. Sometimes the building halfway through they decided to put detectors inside the apartments. The building is 5 floors raised, they decided to put sprinklers on the apartments. So decisions are not taken initially. To avoid that, it's always better to go through the specification, go through the requirement, what is required, design your building, get cleared, then proceed on that. Same as on the other side is the chapter 5 on the fire protection side. That also we have given a table. That table shows purpose scope, height of the building, whether you need fire extinguishers, whether you need hose shield, whether you need landing wells, whether you need sprinklers. So if you need, say, if you want to see whether I need my building sprinkler, you can refer this. What is my purpose scope? What is the height of my building? Whether I need sprinklers. You don't have to go to the fire brigade and sit for hours and ask them whether I should need sprinklers. What you can do is you can design your system, go with your drawings and get fire brigade approvals. Earlier what happens, we were going to the fire brigade asking their requirement, spending our time. But here is a guideline. You can design, take your drawings and get it approved. Portable fire extinguisher, any other than the houses, residential houses, any other site, you need to have portable extinguisher. Maximum design pressure. This is another thing we had incorporated. 20 bar. You can't exceed your fire pump or the pressure in the system more than 20 bar. The NFPSA is 23 bar. There is one project in Colombo. Now they are requesting 30 bar pressure. Right? Now if your system is 20 bar, what should be your testing pressure of the pipes? 1.5 times of the design pressure. So if it's 20, it's going to be how much? Other you have to add, it will come up to 30 bar. The GI pipe maximum burst pressure is 40 bar. So then you have to go for PN25 of 40 valves. So many things you have to, so that's why we have put 20 bar. Why people are going for high pressure? They want to avoid putting pumps on the center of the building. See, some projects they have done here in Sri Lanka, they have pumps on the 29th floor or 30th floor, they have pumps. So they transfer water, they have the water tanks. The balance sector is run by those fire pumps. So if you have a high pressure pump, what they are going to do, they want to knock off these pumps at the middle stages, right from the bottom, they want to pump the water. Hose shield, any building which is over 800 square meters, you need to have a hose shield. I am just running through. I have 53 slides to cover in 60 minutes. These are all, these are not my words, these are all in the document. Landing wells. Any building over 900 square meters, you need to have a landing well and over 18 meters height. What is a hose shield? Hose shield is a first aid where people on the building can use it. Landing well is equipment, carries water where the fire brigade people will come and use it during fire. Maximum pressure is 5 bar, minimum is 4 bar at the landing well, and flow rate is 500 liters per minute. Now people are still, some engineers, they design the system, even the pressure is say 11, 12 bar, still they keep on 1500 liters per minute, because the landing wells, 3 landing wells must operate. That means the fire pump should deliver 1500 liters of water. 1500 liters per minute. 3 landing valves should operate, that means 500 into 3. So what happens when the building is high, when the pressure is high, there are no pumps where they deliver 1500 liters, say 15 bar. So you need to increase the liters, maybe 800, 900 or 1000 liters per minute. External pillar hydrant, any building footprint area is more than 1000 square meters, you need to go for a pillar hydrant. So it's very clear, any factory which is over 1000 square meters or any housing scheme where it has 100 units, you need to have a pillar hydrant system. Breaching inlet. Now traditionally we had only one breaching inlet, but with the high-rise building coming up and the super high-rise building, you need to have an additional fire inlet, brigade inlet, to pump water to the sump. Because the fire brigade vehicles cannot pump water more than 10 floors or 14 floors. So if the building height is 60 meters, you need to use your internal fire pumps to pump water. So that's why. So the capacity of the water tank is limited. So when that is over, you need to have the fire vehicles pumping water to your sump. Another new thing which came up is the fire protection building under construction. If the building is under construction, if it's less than 60 meters, you need to have a dry pipe with a fire brigade inlet, and all floors must have a landing valve. If it's more than 60 meters, you need to have a wet riser. Wet riser means the system is fully charged. Dry riser is you don't have water, but you have an inlet. When the fire brigade vehicle comes, they can pump water. And breaching inlet you need to have. Power supply, you can take it from a generator, that is acceptable, and you have to have fire brigade access facilities 4 meter wide and 4 meter. It should be 4.5 clearance to the side. Portable fire extinguisher shall be provided at each floor level. Now buildings under construction, fires had occurred. I have experience, I have heard many buildings getting caught fire under construction, but no firefighting facility. Right? So it's always better if you are designing a building, when you are reaching the say 20th floor, that you have your fire pumps installed and the riser working. So then you are protected. Right? Sprinklers, I will not go into detail. All indoor car parks and any high-rise or super high-rise building needs to be sprinklers. Some they get a exemption saying you have fire doors, my apartment is no high risk, we don't need to do sprinkler piping. How can we do sprinkler piping? There's no ceiling, right? Then the pipes are exposed, right? But any high rise and super high rise building need to be sprinkled. There are ways or means of hiding your pipe. You can have side wall sprinklers and take the pipe on the wall. So no excuses for super high rise building and high rise building. A new thing we have introduced is the combination system. NFPA 14 allows it, and now previously any building which was less than 30 meters, if it had sprinklers and hydrants, we used to have separate pumps for sprinkler and hydrant. Future, any building less than 30 meters, if you have sprinklers and hydrants, you can have one pump set, one riser. So having another pump set is not a requirement now. And always the fire pump has to have a positive suction in. I hope everybody know what is a positive and a negative suction. Fire pumps has to have a positive suction. The BS allows negative suction with a priming tank, but we don't recommend priming tanks suction, because I have seen, I have done buildings, now the suction is negative suction, but now they have problems. They have problems. Pipes are corroded, you had underground piping done, you can't replace the pipe, you have put another structure on top of that pipe. So many things happen. Pump shall be capable of satisfying flow and pressure requirements of assumed area of operation under consideration. That means it will have flow rate which is the minimum flow rate of the sprinkler plus the hydrant requirement. So the minimum for light hazard is 1100 liters per minute, hydrant is 1500, you add the two is 2600 liters per minute, your pump should deliver water. So combination system, one pump, but the flow rate is high. The pressure has to be the pressure required at the most further point in your system. Now pumps for sprinkler and hydrant hostage system, separate pumps shall be provided for hydrant and sprinkler installation other than the combination system. Any other building, any super high rise building or high rise building, there should be separate pumps for hydrant and sprinklers. Drivers for pumps as single installation shall either be electric or diesel engines. For super high rise building, we have introduced a diesel engine, or alternative you can have a generator supplying direct current to the the fire pumps. It has to have a the backup facility of a diesel engine. Imagine you have a fire, say Chandrila, 54 floors. There is no power. What are we going to do? There is nothing we could do. Only start up the generator and run the pumps. So super high rise will, as much as possible, try to have the standby pump as a diesel pump. Fire pumps will be listed for the application. Most of the projects we have water pumps running in the fire system. We have blue colored. Color is immaterial, but the performance criteria doesn't meet the requirements of a fire pump. I will show a diagram later. Pump shall not have two drivers, two motors. It will have only one driver. Each fire pump will have its own controller. Now, for the previous design we were doing, we had one controller giving controls for the maintenance standby. But for high-rise building, a super high-rise building, each pump should have its own controller. So as per UL listed, is one pump with a one controller. Right. Another thing, or the pump churn pressure. What is the churn pressure and the shut-off head? What is the difference between a shut-off head and a churn pressure? Shut-off head you can test at the factory. You shut off your outlet and you run the pump, you get your shut-off head. Churn pressure is you run your system with no flow condition. You have a pumps running, you close all your valve, but the head will come to the fire pump. So it's running no flow, that's the churn pressure. You have to check the churn pressure of the pump and it should give that required pressure at that ground level. Otherwise your furthermost hydrant will not work. Rated capacity, that is the pump will discharge at the rated pressure and the flow. Overload of the pump, discharge water at the rate of 150%, rated flow at the pressure of 65% pressure drop. What has happened? Now what happens is when you have three hydrants, 1500 liters per minute running at a different pressure, when somebody opens another valve, what will happen? The pressure will drop and the flow will drop. The flow will be there but the pressure will drop. The fire pump, there is a requirement. The fire pump, you should maintain 100%, 150% of the design flow rate, and when you achieve that 150% of the design flow rate, the pressure should not drop below 65% of your pressure. Example, your pump is 10 bar 1500 liters. What is 150%? 2250 liters per minute. So the pump should give 2250 liters per minute, 65% of the pressure. 10 bar 65 is 6.5 bar. So the pump should not run at 4 bar and give 2250. Another thing what I have observed, the rated capacity. Now this I am showing a small pump curve. I hope we have few time. There is a design point. This is the 150 flow rate. This is the shut-off rate. What they are telling is the power. Normally when some people they quote for a fire pump, they only calculate the power required at this point. They don't calculate the power required at this point. What happens to the power? This is the power curve. At the design point, the power is less than 30. It's 28. But when it reaches the flow rate, 1500 flow rate, when people open other valves, what about the power goes up? The requirement for power goes up. So if you order a pump which has 30 kilowatt, what will happen when you have the flow rate, right? The pump will burn, right? So people try to give, the price is low, they play out with the price, but you are not achieving your design point, right? So always you need to check that. But we are telling is that the regulations say 150% of the flow rate, your pressure should not drop 65%. This is there in the flow rates are there in the document. One key point is, now there are buildings, you have tower 1, tower 2, tower 3, or in each tower you have 2 or 3 risers. Now earlier we had 1500 liters a minute at a given pressure. Now what happened? When you want to add another riser, earlier there was no requirement. Now each time you are adding another riser, you have to increase the quantity of water by another 500 liters. Maximum up to 3000 on a hydrant, 2500 on a sprinkler system. I hope it is clear. Now you have a system, one riser, pump is given 1500. Now your building is multi towers. You are using the same pump. Then what you have? Other risers you have to add another 500 liters of water each, and maximum up to 3000. Next, if you are exceeding that, you have to go for a different pump. All these pumps, the fire pump should have positive suction. If you can't achieve positive suction, you must go for a vertical inline turbine, vertical turbine pump. If the client says, I don't have space to put up the tank on top of the ground, yes, you can go down, but you need to go for this type of pump. Automatic manual pumps will run automatically, start automatically, manually it must be stopped, sprinkler and hydrant both. Once the pump start, the audible signal must go to the pump control room, where the fire alarm control panel. So the control room people should know the fire pump has started. Power supply has to go pass in the DB line. Auxiliary power supply should have auto transfer switch. No manual transfer, it should auto transfer to the diesel or the generator power. In the event of main power, both pumps are electrically driven, alternate power shall be provided to the operation of fire pumps. The standby power should go to both pumps, not only to the standby power. So the power has to be given to both the pumps, not only the standby power. Don't think that standby power is for the standby power. Transfer of power, control between the normal supply and the alternate power shall take place at the pump room. This is debatable. Most of the people, they want to bring one cable from the transformer. What the NFPA says, 2 cables has to come to the pump house. The transfer of power should take place at the pump house. One cable coming from the CB power, other cable coming from the generator power. The transfer ATS should be at the pump room, not at the DB room, right? And some people design, some engineer design the pumps to be at the rooftop. Here is a good design. You can take the advantage of the head, but you need to run your cables, fire rated cable, up to the top floor. So what happens in case the pump doesn't start? Some defect. Somebody need to run up to the pump house during a fire. Who is there to do that? Are you trained? Our people are trained to do that. I was in the fire brigade for 5 years at the time of war. The Air Force took over the fire brigade. There was a fire at Kalanitissa. I said, let's go. The civil firefighter said, sir, apita araksha deno, apita rakshana deno. So the guy at the pump house will say, fire udata gilla pump එක බලන්න. Sir, මට insurance දෙනවා. That time. Who is going to go there? In chance you have to go there, you have to have a protected stairway up to the room, protected corridor to the pump room. So the design is good, I am not arguing with that, right? But there are plus minuses, right? Chapter 6 talks about use of occupancy structures. Two important points: separation of kitchen, very prominent thing which is coming up. You have open show kitchens in hotels. When you have show kitchens, you need to have a separation wall. Now, how to have a separation wall? You have a show kitchen and you are putting a wall. What is the purpose? There is no show in it. So what you can do, you can have a fire curtain. It's always open. On a time of fire, the curtain will come down and give a protection, give the fire resistance to that, will make it a compartment. And if a show kitchens are there, you need to go for a fire suppression system, kitchen hood fire suppression system. Chapter 7 talks about accessibility for the firefighting vehicles. Now what happens? We put out the building, everything is fine. All done as per standard. But we put up a pond in front of the building, or we put up a barrier which opens halfway, vehicle cannot go. So you need to keep 4.5 clearance up and sideways for the fire vehicles to enter. And especially if a high-rise building, you need to have a hard standing. What is a hard standing? This aerial ladder platform, this must be lifted. Before it lifts, it has to have its jacks jutted out, and the vehicle will come, will be standing on the jacks. So you need to have 6 meters clearance for this. Now what happens when you, and the hard standing must be minimum 2 meters from the building, maximum 6 meters. Now most of the buildings we have podiums, we have seen podiums, and after the podium only the structure starts. Now how can you approach the flow from this vehicle? The fire brigade has vehicles up to, which can reach up to 10 floors. If there are people trapped, they can give them people using this aerial ladder platform. But what happens, you have the podium, you can't take a vehicle inside, right? So this is another area you need to look at, vehicle accessibility. Then another important aspect we have put it is the inspection and maintenance. And all system has to be maintained. We have given periods, what type, when, by who. These are the system has to be maintained by the client or the occupier. I hope everybody now walking into a lift thinks of an incident. When you get into the lift, you think of something. You think of the green building incident. People are scared to go in the lift now. When I tell my wife, we'll go, no, she says, we'll walk. Right? So just imagine the one incident which has given that much of fear into people. So the fires will give more fear. Right? To avoid that, these are the guidelines. Inspection and maintenance, there are routine inspection, periodic inspection, inspection by the authority having jurisdiction. We have put it black and white, and people need to comply. Inspection routine once a month, periodic inspection once in 6 months, or as per manufacturer recommendation. Inspection by authority having jurisdiction is by the fire brigade once a year. And you need to get a certificate. The fire pumps must run for 30 minutes weekly. Electrical pump should run for 15 minutes. These should be recorded and kept. Why? Next time there's incident, somebody is going to come and ask you, where are the documents? It happened at Green Lanka when the lift went. Where are the service? Where is the contract? Where is the servicing records? So many questions asked. So the fire, it will be worse. Tests shall be carried out to ensure the system controls are working in mode. Annual testing by a competent person or certified by authority having jurisdiction. Service contract, we strongly advise to go for service contract, but there's money involved, people, but you can have your own team. But always, if there's a system installed by a reputed party, you have to get it checked by that manufacturer's representative. Documentation has to be kept, had to be provided on authority having jurisdiction on their request, and it has to be maintained. A certificate of compliance shall be issued by the certified inspector at successful completion of period inspection. The owner of the occupier shall retain such certificate for the inspection by authority having jurisdiction when required. So these are important. Why you say important? These are in law. You need to comply with this, and someday this document will come in handy. Conclusion: compliance to regulation. What I say is, there is a regulation, comply to this regulation. Check your own decide, past and present. Don't go to check others. Check your own decide. The systems you have done, what are the failures, what you have not done. Because as I told you, someday you will be there inside that building, or your parents or some relative will be there. And I hope nobody wants to see their children thrown like the incident we saw, right? So it's everybody's concern, everybody's responsibility, and finally it's your responsibility. Responsibility cannot be passed on. So it's the end of my session. It's almost 1 hour. I also stick to 1 hour. So we can go for questions. Better you get a copy of the document, and maybe some questions I can answer then and there, maybe some questions, because this document was done not only by me but certain other professions were there, ISL members were there, so their input was also there. So some question we can, if I can't answer, we'll have it answered to it.
This fire systems inspection, periodic preventive maintenance must take place in the electrical system. Most of the fires need some sort of electrical failure. Therefore, electrical authorities and the fire authorities jointly check this electrical fire. It will be not subtle. They will see this electrical failure. There is a problem for many case studies, many fire case report says it's a electrical failure.
Correct.
Then no point of checking only the fire system.
Yes.
But we check together with the electrical system. There are so many other places also, other areas also to check. But mainly fire system plus CEB, once they supply this thing, checking their system okay. After that, so much of any house, so much of extension against to the electrical regulation. Then it may go to the fire. And the low quality extension cords and other things. That is the main thing. The other one is this, for the periodical checking, no competitive person, not sufficient competitive person for the private sector authority to check. That is the major failure.
Yes, thank you very much. The electrical, actually what happens, the fire system has two parts, fire detection and the protection. So fire detection is always correct. electrical is there, but you have battery backup. Battery system is there. So that's why we were telling it has to have minimum requirements of a battery backup, secondary power. Only the fire pumps, especially the high-rise, super high-rise building, yes, electrical is a major component. That's why we are asking go for a generator or a diesel pump. People don't go for diesel pump because of maintenance, high cost maintenance. But time of disaster, I think the diesel pump is the best option. So even we say in the documentation, before you commission a system, especially the fire pump, a certified electrical engineer must check the system and give his certification. I have experience. I have commissioned pumps. He has seen the breakers going off. Right, so many incidents happen. Right, so some people they don't do it properly. So it's a combination. Not only electrical, even the civil structural. Right? If he doesn't do the staircase, the escape routes. Recently, I don't want to mention the name of the project. The escape was like a very sharp, what do you call that? Max light, right? The gradient, we have a gradient of 37, I think 36 or 37. This was way above, right? But so not only electrical, mechanical parts, the fittings. You have the UL listed pumps, you spend millions on the UL listed pumps, you put an unlisted valve, you put an unlisted flexible coupling, the entire system is gone.
The thing is now the calm megapolis, so many high-rises building comes out, but the municipal fire hydrant system, actually, any improvements done because it is very old.
Yes, I think that is also been done by a Korean team. They are now putting up, the water board is putting up hydrants. You can see if you go to certain places, you will find new hydrants coming up. New hydrants are coming up. So it will happen, but it will take time. That's what we are telling. You don't depend on anybody, especially high-rise building and super high-rise. Your system has to inbuilt to the building.
Problem is local UDA and the local authorities checking all those things, but no proper fire regulating job other than the municipality authority. Yeah, it is required.
Yes.
Fire regulating.
Correct. No, that's what we are trying to push. We are trying to push. SEDA is trying very hard. SEDA director is here. We are trying to push. We are going to educate. We want to conduct seminars, educate the engineers. Right? Engineers play a major role. Right? They should know the regulations, and within some time things will happen. But the disasters will also happen.
Other than the UK qualified fire engineers,
yes,
we have so many universities. Out of that, I think 20 universities are in the engineering.
Yes.
Faculties. But some of these universities having any degree
Correct.
in fire engineering or whatever.
That's what another aim. What I am trying to do. Now I am retired from the private sector. Now I want to do with the Unitech. We want to develop a degree program on fire. At the moment, we have the building services technicians. We are up to level 5, I think. Level 7 also they are doing BSc engineering courses. Similarly, we want to have a fire technician NVQ level up to 5, up to 7. So 7, already I am discussing with Unitech to develop a degree program in Sri Lanka. So you will have a not 4-year course, you will have a degree course. First a professional course for fire, where the mechanical engineer or electrical engineer can complete a degree program. Because not only the engineers, the fire brigade also have to be educated. We'll see. Time to come, we'll do. We are definitely trying to do.
One is about the video report about recent fire in
Yes.
The question is asked, how the fire brigade respond to that fire, and why do the people have to wait?
Yeah, I don't have much detail, and it's not correct for me, not correct to me to tell anything which I don't know. But if I go through the entire video, you can see after about half an hour the vehicle used to come. At that time, that guy had put all his 3 children plus his wife down, right? And I think I don't know whether he's a commando or a serviceman. The gut he got, those are called situational leaders. Like even we'll have time of accident, people come and they do various things. It comes from them. I don't know from where it came. To throw your child 5 floors down there, and the way he threw was, he didn't just throw it like this. He threw it in a way. Even we also thought when you are jumping, you have to come in a particular manner. Even on the aircraft, you say the slides, they shows. You don't roll, you put it. This guy did that same thing, right? This my personal thing is something. I think he is also responsible for something. That's why he had this gut to do that. I don't know the background, but I felt that he also was a culprit in this incident. Right? Otherwise, that guy to throw his children like that, my God, the courage.
My second question is about supply. What supply situation, regulation, whether it can be a fire to fight as a building. I was in that unfortunate situation. I was working since around 83 July. 83 July, racetrack started, and there were so many buildings that were on fire.
Yes.
And there was no water because there was a drought at the same time. We were running on meters. Now, with all these regulations and we have think that meet all these requirements, but the supply can't meet the demand. What are we going to do? I'm just also comparing to what happened in the recent fire exit. Now, with all that so close to London Center,
Yeah.
they couldn't go with it, and how are we going to deal with it?
Yeah. So who is going to fight fires? Not you and I, the fire brigade. The fire brigade has to have the equipment ready, and all those equipment should be there. Now, I personally feel we are ill-equipped. We are not up to that level, mainly due to lack of funds. They can't procure anything, right? 30 years ago, I purchased so many vehicles. So still those 5 vehicles are still running. So we purchased 3 aerial ladder platforms. After that, they could not buy aerial ladder platforms. Only they have got up to say 20 meters height. When I was there, I purchased for 54 meters and 2 30-meter ladders. Right? So there's a problem of funding, but these things should be addressed. At least take some money from the developers, put it in the fire brigade, develop them, right? So we are, as I said, we are waiting the situations happen. Things happen, then only people will open their eyes.
That's the problem with graduate. Now all these buildings are investment going in, and so people are occupying this building.
Yes.
It's like doing a business. Because if the fire, even if the engine can cope with the fire, but there must be a supply. If you induce the fire flow into any of the regulations around the building,
Yes.
you can't supply to start cutting the air. I know one example, my present experience, because President's office was without vote.
Yes.
There was some to find that country by the water, pressure was down. To find that the kids around there, they got one of the officers had open it on the bag so that they all the back into the cup.
Correct.
Because they were scared.
Yes. Can we just one? I like to answer. Maybe we can talk. Shall we focus only on questions on the regulation, right? Otherwise, then I am also talking on somebody's behalf, which is not correct for me to do, right?
This is your question. When you say that regulation, see that act. Does it cover the fire rating of materials to be used?
No, that gives. We don't go into rating of fire material, but the fire doors we cover, the fire walls we cover, the rating of the fire walls, those are covered.
And also the control.
Pipes, what type of pipes to use? Now there was a question whether we can use CPVC pipes for sprinklers. Some people have seen they are using HDP pipes for sprinklers. You can use CPVC pipes provided that they are used for light hazard application and they are rated, they are listed for fire application. But you can't use normal CPVC pipe which we are using for plumbing for fire. You can use HDP pipe for underground piping. But the moment you are taking the pipe out, you have to convert it to a GI pipe.
There are some fire instances which very popular due to in one case acoustic panels and auditorium was on fire. Or auditorium fire, acoustic panels were on fire. So fire spread lot. In one case, insulation, some heat insulation was on fire, so fire spread. So are there any guidelines when you're selecting acoustic panels or insulation, HVAC, those to be fire rated somewhere in our
Auditoriums.
When we are using materials for various construction, for various purposes, so acoustic purpose, it could be insulation or many other purpose, those to be fire rated.
We have, say,
Yeah, I tell you things that I think there are a lot from regulator very much. There was a fire 2 years ago in UK, the Glencore fire.
yeah,
And yeah, it was evident that incorrect installation method, actually the very cheap
cladding
system was used
Yes.
that created fire.
Yes.
And the fire, even though the entire fire picture there, fire people who entered the building and 71 people died.
correct.
And the irony is that the people defied the order, that is the traffic system announced them not to leave.
Yeah.
But people who stayed, they perished.
Yeah.
People who defied the order, they came out. Now, it shows that incorrect installation and inferior materials for fire, this is a problem. UK now is a huge issue.
Correct. We have included in the fire regulation the cladding. Cladding had to be fire rated. Every 3 floors, the cladding has to be sealed off, so the fire will not spread externally. That is there. How far it been done is a question. So that's why these regulations must be implemented. Say then fire rated material, as you said, we are telling them to use fire rated material. Then the curtains, putting fire curtains, then the water spray curtains, those things like this museum's fire, right? Fire brigade was not even say 2-3 kilometers away, but the entire
All these I didn't mention the name, but then there is acoustic panel.
Yes.
And also not fire, it fires very fast. And also one major fire or in a BOI zone, one other large industry,
Yeah.
that is also due to one insulated material. So I was just wondering whether other countries, I saw certain fire ratings, so each and every material that are used, there are certain fire ratings given.
Yes.
But here not very thoroughly.
Yeah. No, certain people who knows the subject, who's caring. Say, one hotel contacted me for fire rated painting. They want to paint the curtains with fire rated paint. So they are concerned. They don't want to because their owners did not approve the curtains without fire rating. So there are paints you can apply where you can keep it for 1 hour, 2 hours with the paint.
I think probably locally we need we have to have some guideline or specifications for those things.
Yeah, thank you.
There might be places where we cannot use both as fire suppression materials. So that my question is, there might be places where we cannot use both as fire suppression.
Yes.
So as those kind of places, it has been covered with this regulation.
Yes. Say now computer server rooms. No, the thing is we are talking about life safety. We are not talking about property safety. Life safety is a concern. So if you take a bag, whether we are concerned about their wallet, where computers, backup systems, whether those things. So NFPA clearly says any room has to be sprinkler, whether it's electrical or non-electrical, has to be sprinklers, right? But thing is, you can't have a water spray on an electrical panel.
Sorry,
Yeah.
petroleum or something.
Yeah.
Water is like the fire can keep the.
No. So petroleum for the fuel stations, there are under this guideline there are different clauses, right? This is a guideline, but this is not a guideline for designing guideline for designing, but it's up to the engineer to decide what is the medium to be used. Say we can't put everything here. Say we can't put for storing petrochemical, storing firecrackers, storing explosives. Certain areas we have touched, but not in detail. Maybe the next revision it will be, we will improve on this and cover all those areas.
In occasions, is the fire takers the gas cooker.
Gas?
Gas cooker.
Yes.
For kitchen. Any, it is mandatory. Is there any mandatory regulation to use the, every house must have a fire brand? Very simple.
No, it's not mandatory here.
Because this for the first step.
Yes.
First action for the fire brigade to prevent the fire. Matching the the fire brand. It must be mandatory. For gas to cooperate, takes over to fires.
Yes. I think future we can put that in the household. Say even if you go to USA, every house has detectors. Without the detector, they won't give. In Australia, they have. So we are going into that, but at least we start somewhere. Because if I go and tell my wife, even we'll put detectors to my house, she will say, why can't we do something else with that money? Right? Yeah. Right? But even my house, I am having extinguishers. That is for my, because I know the risk of fire. Right?
Regulation for gas.
Yeah.
Explosion point.
Correct.
There should be some.
Yeah, under this regulation we cover the gas installation. We have to keep the gas storage, the ventilation, the distance from the building, everything is covered. I didn't go into detail because the time was correct. Yeah, but basically, as say responsible people, we have learned something, right? We must tell our wives what to do. I had told, if you come to the kitchen, first thing is look for the smell. Our friend, one of our friends had an incident. He switched on the light. Yeah, right? So it's always, don't wait for regulations. These are common sense. Common sense. If your cooker is on fire, what to do? Right? You must have that knowledge. You must tell your children what to do. Right? How to, if I ask you how to call the fire brigade, how many of you can tell me the number? Can you tell me the number?
Those days they gave by.
Huh?
Those days they gave by.
Now is not those days, now is current days.
Yeah, my question is, you introduced the concept of refuge flow.
Yes.
Is that an introduction for recent revision or was it these?
No, this recent introduction with the super high-rise building.
So which means, so at the moment, buildings which are in fact super high-rise, qualified super high-rise, they are not compliant.
No, now at the moment there are buildings with refuge floors. So fire brigade is insisting that they have to have refuge floors. These are all new things that we are learning. Fire brigade is also learning, but we need to comply.
Existing buildings, is it possible to retrofit that kind of refuge flow?
Now refuge floor requirement is over 60 meters. So existing building, I don't think any building is over 60 meters. 20 floors. 20 floors, but maybe twin towers. Yeah.
The locust tower.
Yeah.
What is the evacuation procedure that you have?
Lotus Tower.
Locust tower, so it's a tallest building. Now, do they have?
They should have. I don't mean to that. They should have.
And how do they evacuate?
No. They should have. They should have fire lifts, a fire shaft. They should have.
Yes.
Just correct me if I'm wrong. As my understanding, fire brigade give 125 cubic meter fire sound for almost all the buildings of all sizes. If there is any basis or with the number of floors increase.
I didn't get you. What's up?
Capacity of the
So the fire sound, fire brigade normally recommend 125 cubic meters of fire sound.
Yes.
For almost all the buildings.
No.
There is what is the
Now
basis
these
of-
regulations clearly says if you have sprinklers, if you have hydrant, the quantity is given. That is calculated for half an hour or 45 minutes, right? 45 minutes. It's now it's like prescriptive. Like when you go to a doctor, he will touch your thing and he will say, you need Panadol, you need this pain, everything. He will give. Fire regulations are prescriptive types. These are document. It should be the designer should be aware. It should be performance based. Performance based is different from prescriptive. Now this regulation will say 125 cubic meters or 67,000 liters salt. But now you are putting up a hotel, you are putting up a shopping complex, you are putting a high-rise building, mixed development. So now as a developer you think my 60,000 is not enough. I know the fire brigade capabilities, I know my structure, I know what type of equipment I am using. So the designer can increase. Don't wait till the fire brigade say 125. You can increase. The problem is you don't have space to do that. Right? So always this is a guideline to give the minimum, but you have to do a performance based fire risk assessment of your building and see what is required. See, now we say 1500 liters per minute. That's the hydrant. For the sprinklers 1100, 1350. The building, what we have done, the Singaporean consultant had given 1000 gallons per minute. So the requirement is 1350 liters per minute. So he had given 3700 liters per minute, the pumps. Why? He had done a performance based evaluation of their system. So these are minimum. Right? I hope it's clear.
It is clear, but I'm not sure how to do the calculation.
It's very simple to do the calculation. If you have a hose reel system, the design says, the specification says 2 hose reels has to run. So 1 hose reel is 30 liters per minute. You need to run 2 hose reels. That is 60 liters per minute. 60 liters per minute into 30 minutes is 1800 liters per minute. So you need to have a tank of 1800 liters. Now if you are having a hydrant system, is 1500 liters.
Announcement.
Yeah.
Vehicle number HA7155.
88.
HA owner vehicle number is looking at the number is HA7155.
Number 7155. Vehicle number 7155. Okay.
Thank you very much. Sorry for disturbing.
No.
Now we are about to finish the session, so let me give time for one more question or 2 questions.
This is not the question. Can you release this lecture to our Indian ISL website? Maybe you don't mind.
I think you are updating anyway. You are updating.
I think it's not.
Video is updated, streamlining, and you can view it.
Yes. Fine.
I am Suran Fernando, Chairman, Building Services Engineering Sectional Committee. I think we have done big injustice to the lecturer because giving 1 hour for a wider scope subject like this, fire regulations, I think. But in the meantime, he has done enough justice to that subject area, picked the most important chapters and handpicked the most relevant and the areas he want to explain to you. I think he has done a delicate and tremendous done that well. I should thank Mr. Kolitha Srinisankar for this wonderful lecture and interesting QA session. And then after, I think I have to give my appreciation to the ISL management as well as the administration. In the meantime, a gift is ready, a token of appreciation is ready to offer. Let me invite our senior engineer, past president, engineer Chula De Silva onto stage to hand over the gift of appreciation to Mr. Kolitha Srinisankar. Thank you, Engineer Chula. This will be the one of the most interesting lectures we have seen. So, with the Building Services Engineering Section Committee, hope to organize similar events, similar activities like public lectures in the future as well. I think we'll let you know through the ISL mail. We'll expect you to participate for the next events to come. Thank you very much. Goodbye and good night.